Welcome to part 7 of this video series that describes making a small steam test plant. In this video I'll be making the chimney stack and superheater for the boiler. Before starting to make the chimney stack components, I designed them in Fusion 360 so that I could check sizes and use the drawings as a guide when machining. This drawing shows the base of the chimney stack. This drawing shows the top of the chimney stack. The base and the top of the chimney stack were machined from a piece of 2-inch diameter brass bar. I didn't take a lot of video of machining the base and the top of the chimney. The process for both took quite a while, and condensing it in YouTube video would have been tough. This clip shows me finishing turning the chimney top. After machining was complete, I rounded edges of the chimney top with a file. After one side was complete, I turned the top around in the chuck and rounded the remaining edges. I made up a nozzle from a piece of 3/16" tube and a union connector. This nozzle will screw into the chimney stack for the outlet from the condenser oil trap to connect to. This photo shows the base, chimney stack, chimney top, and nozzle assembled on the boiler. I had filed a concave profile on the bottom of the base so it sat on the boiler cladding. I left a small gap to avoid the cladding getting burn marks on it. I then spent quite a lot of time silver soldering the components of the chimney stack together. The process involved cleaning surfaces, fluxing, soldering, and pickling each time a soldered joint was made. This clip shows me silver soldering a bush onto the base of the chimney stack that connects the steam from the boiler to the superheater coil. I took care to avoid overheating the chimney stack and melting previously soldered joints. Eventually everything was soldered and I was ready to move to the next step and make the superheater coil. I started the superheater coil by annealing a piece of 3/16" copper pipe that I had filled with sand. Annealing the pipe softened it so I could bend it. Filling the pipe with sand would allow the pipe to be bent without creases being created. After the pipe had cooled, I bent it around a mandrel held in the chuck of the lathe. When I felt the copper harden, I would re-anneal the pipe by heating it and then letting it cool again. This clip shows me finishing the coil of the superheater. I then re-annealed the pipe and bent the ends over by 90 degrees. The ends of the pipe locate in holes at the end of the bushes I'd soldered onto the base of the chimney stack. I inserted the ends of the superheater coil into the holes in the bushes on the chimney base. I fluxed the parts and then soldered the coil to the bushes. For this operation I used a lower temperature silver solder to avoid the solder holding the bushes to the chimney base melting. After pickling and cleaning the chimney stack arrangement, I did a soapy water test using air to make sure it was not leaking. This clip shows the arrangement on the bench with an air hose connected and me using soapy water to detect any leaks. There were no leaks, so bending the pipe and silver soldering had been successful. This clip shows the finished chimney stack and superheater installed on the boiler. This part of the project took some time, however, I am quite pleased with the result. I'll end this video here as the chimney stack is now complete. So, that's the chimney stack and superheater completed. In the next video I'll be putting finishing touches to the steam plant before running it. Thank you for watching this video. Please like and subscribe to support my channel. Thank you.